Another test for it would be, let's see if we can square a block up. So let's walk through squaring a round section of bar up, and let's see how square we can make it. With a brand new 4-jaw chuck, it should be a very, very easy task to make a square piece of steel in a 4-jaw chuck. This is so far out of tolerance, it's unbelievable. The only way to sort this out would be to measure every single part of it and then get a good running 4-jaw chuck and put that faceplate in out of square enough to make up for all the discrepancies in this 4-jaw chuck. Right, so here is the chuck with a piece of high-speed steel ground rod in it from a UK source, and it is clocked in okay, but out here you can see this movement. So that's the high and that's the low, and that's why if you look here you'll see a low, and right here you'll see a high. So I am going to dismantle the chuck and I'm going to measure the faceplate. That's plus half a thou, that's minus a thou, that's plus half a thou, that's plus half a thou, that's minus half a thou, and that's minus a thou. So there's a thou and a half in that faceplate for a start. Alright, here we are back again. As we can see, I've took off the chuck. I'm very unhappy about having to take the chuck off, and the run out on my disc bang on. Sorry about the glare. So let's turn the light off it a little bit, try and get the glare out. So there's no discrepancy in my back plate. Alright, the chuck, it is back on, and as promised, the low is where the high is. I've got high there, low there, low there, high there. So I haven't took the bar out. The high-speed steel shaft, that's perfectly on 0. Switch her on, and there is a massive run out there. Yeah, you can see that. So as we can see, this chuck I didn't take that out. So that should go back on and be almost identical to where it was. And it is not. It is not even close. You see, the chuck body's got 3 thou in it. And, well, if that even corresponded to 3 thou here would be great. Anyway, let's clock it back in again in the new position, because if it is good now, I'll be happy. I don't think it will be, but if it is, I'll be happy. So there's a low right there, so we'll take the low off a little bit, lift it up a bit and go down to the high, which will be that. Move that down a bit. There's a low. Undo that a little bit. And there's a high. There's a high. There's a high. There's a high. Alright. So as you can see, that is probably 2/10. And now it is not nearly 2/10. It is 3 thousandths. And there it's like a 1/10. So, some might say that you can bang that straight, or you can bang that as much as you like, but this shaft is grabbed on the full width of this, and the only thing you're going to do if you can bang that is you're going to attempt to bend a piece of high-speed steel, and let's face it, that is not going to happen. So let's see where the high is. There's the low, and that's where the low was. Yes, there's the low. Let's see where the high is. That's where the high is. That's where the high is. That's where the high was. So the whole problem is definitely in the chuck. Right, this is not too clever, this test, but it is the next test in line. I don't want to be hitting the text, so we'll try and adjust out of the text. Maybe that's good. And I want to be rotating backwards. I want to be going really slowly. I'm going to bring it up for a touch. And that seems to be good. So that looks to be consistent, to be fair. So the chuck body at the outside area is good. Let's try the inside area. Yep, and that's hitting the same mark, 3 thou every single time. So I'm quite happy that the chuck body is parallel. Right, now I'm set up. You see the dial test indicator down here. And that's a 0. And we're on the cross slide now. So we're going to test this face here. That's 5 thou, 6 thou actually. Come off the end. And back to 0. It's a thou down. That's 0. That's a thou down. That's a thou down. That's a thou down. Just looking for consistent readings. Okay, they're all a thou down. Right. So let's go with this one. This is the one that says high on it. So this is getting higher towards the centre. So this is convexed. That one is 3.5, 4 thou. Oh yeah, it's 5 thou because it's 1 thou down. That one's on 0. No, that went to -1, sorry. This one looks better. Yeah, that's slightly better. That's got 5 thou in it. So we've got between 5 and 7 thou convexed. Which is automatically making the jaws bell-mouthed. Right, we are going to do a test of the 4-jaw chuck in operation, if we can stop the camera from wobbling. Obviously, for setting up, I will need a dial test indicator. Okay, decision made. I'm using this left-hand turning tool to bring this roughness down close to the diameter. At that point, then I'll be able to get the gauge in. Sorry, the DTI holder on the compound. So, if we tap this in a bit harder than that, copper face. That is now a 0.2. So write that one out. Get that out of the way. On to the next one. Up there. Righty ho, here we go. The back face is running absolutely true. Right, there's the measurement. It is 455.7. So yes, doing stuff like that, blending in lines, it can do, but so it should. When you take, you know, 20 minutes, 30 minutes setting that up, I can just feel a bit of a blend line there. It's overcut there, so it ain't perfect. It's not perfect, but it ain't bad. It's perfect there, absolutely perfect there. So yeah, it's still concentric and not concentric. Let's see which bit is out. So it's got a couple of tenths there. Onto my surface it's perfect, or on the surface of my hole block it's perfect, but you come onto the surface I've just cut, it's doing all manner of things. So it's pretty good there. Tell you what, let's Scotch Brite it. Give it a bit of a chance and Scotch Brite it. Oh, that's better. That's pretty good. That's good. Looks like I overcut by around about 3/10. This is 3/10 down, so that'll be half a thou in total. So I've overcut it a little bit. That's what the step is that I'm feeling. So I'm set up. I've got a chamfering tool in there, and that's what I'm going to use. And that'll do. Right. Let's have a quick look. You're going to shake again for a second. Let's see. This is not very good surface texture, but we'll get a general idea of what's happening here. This is the same test I did for the jaws. We'll bring this into a 0. Okay. And I'll bring it back out to a 0. There. Alright, we'll bring it back into a 0 then. Tell you what, let's go a lock stop on it and hold it on a 0. Right, 0. And chucks in the way. Everything's in the way. going to move it away. Awesome. Well, you get the idea. That was 0 all the way down. And we're ending up at 1 thou. So that surface is level to what the slide does, yeah? So let's cut a level surface. Now it does have a pip in the centre, but could put a crappy straight edge against it, and that side looks perfectly level, and put it right across that side, and yeah, there's no light showing between that apart from the pip. I can't go past the pip in the centre. Apart from that, there is no light shining through that. So it's definitely not rocking. There's no rock like that. Which, you know, that's what these jaws ways are like. So if it was cutting the same thing, I would be getting a side to side rock like that, and I'm not. I don't think it's concave neither. It's cutting pretty flat, to be fair. It's not bad. It might be a little bit concaved, yeah, a little bit, just slightly. And that's the way it's supposed to be. It's supposed to be slightly concaved, not convexed. It's not supposed to be convexed. It's supposed to be slightly concaved, just ever so slightly. And that's what it is. So that is good. As for the lathe, the chuck is not good. Everything I'm doing here is proving that that chuck is not good. We've just demonstrated the crap turning tool. Obviously I've used a 45-degree turning tool to cut that surface down there. It's cut it, and there is less than a thousandth variation from centre to, well, it's hardly noticeable. If it had a smooth surface, then I could have had a better measurement, but there you go. When I measured the ways of the 4-jaw chuck, we saw 7 thousandths on 2 of the jaw ways and 5 thousandths on the other 2 of the jaw ways, and that's where the discrepancy is coming from. The chuck is on land and it cannot move in any direction, and then it's pulled up against the faceplate, the back plate, and the back plate's got no run out coaxially or axially. So negligible, and the chuck body's got 3 thou. It doesn't really matter, but if you've got 3 thou outer concentricity here to that land, then there's something going wrong, basically, already. So from my experience, I would not bother basically buying one of these Sanou chucks, but I will say this: normally Chinese stuff comes with some kind of certificate of authenticity inside it, although it's sometimes a bit of a joke when you look at it. You might think at least someone's written something on it, and this hasn't got one. So I do think this is a factory reject. So it might just be worth buying, if you're going to buy one of these Sanou chucks, probably getting it from a reputable English company. At least then you can get a warranty claim with satisfaction. I'm not sure what's going to happen. I'm waiting for a response. While he's pondering what he's going to do, I'm doing this video at the same time. I've been relaying information, what I'm finding about this chuck, to the seller on eBay, and we'll see what he does for me. I've worked with the guy before, and he's pretty fair usually, so I'm not expecting anything bad from this guy. But you know, obviously there's going to be other guys out there which don't care and don't want to do stuff for you. Anyway, let's take this out of the 4-jaw chuck now, because it's at the point that's all I want to do to it. I can do the rest in the rotary table. So then we'll get it out, measure it up, see if I've got it coplanar to each other, and now I'm ready to use this for what I wanted to use it for. So that is wonderful. So it can do those 4-jaw things, i.e. that kind of thing, but I certainly wouldn't trust it for shaft repairs and stuff like that. But there again, any universal jaw can do that. 22.53, 22.54, 22.55, 22.55, 22.55, 22.55, 22.55, 22.55, so I think that's about 22.55. And let's zoom in onto it. There we go. The Sanou 4-jaw chuck. From my experience, I would recommend that you don't get it at present. Although we haven't seen what the warranty situation is going to be like. This is definitely out of any kind of tolerance for precision piece of equipment. I was just thinking to myself, I can do better than this. If you didn't want a ground finish, I could do better than this on the Bridgeport. I could do it within 3 thou. I've just done a part within 3 thou on the Bridgeport, bigger than this. So, and that's just getting started. I'm going to get better on the Bridgeport as I get more tooling for it, and there's less flex in the situation of the tooling, which I'm just flipping together really quickly now. Anyway, if it had been a good chuck, it had been all square and everything, the small little voids and what have you inside it, I wouldn't have been overly bothered about. I'd have been a bit upset about them. But since the chuck bodies are out of square as well as the chuck jaws not being fully formed, all in all, I'd give this probably smooth operation. No, you know, it works. You've got to give it 1 for working. It's reasonably well ground. You've got to give it another 1 for having a few ground surfaces, so that's 2 points out of 10 having a few ground surfaces. The bolt hole circle is well done. The hardened screws look okay, so I think 3 out of 10 for that. Effort for, let's give 4 out of 10, so I'd say it's probably a 4 out of 10. Yeah, I'd say 4 out of 10 I'd give them for that. So I have this piece of high-speed steel and I'm going to clamp it that far in, so only that far in. I'm not going to put it all the way in, I'm just going to put it that far in. Okay, so we're looking at the gauge here and I'm looking for the low. There's a low, and there's a high, just there between those two. So we'll work these 2 jaws for a start, that one and that one. We'll slacken off that a little bit and tighten that down a bit. And that one's high and that one's low, so we'll do that one a little bit and do that a little bit. That's still low, so a bit higher. Okay, so we need to bring the gauge down a bit. That's low, that's high. High, that's low, that's high. Right. Alright. Okay, that's pretty good. Reposition across here. No good. Okay. But because I've only grabbed a little bit of it, now I can hit that down. So now I can hit it. Too much. Okay, running true. That's right. That's right. Perfect there. Less than a thou there. So that's easy because the clamping here is only very short. But now I'm going to fully clamp it and we'll see the difference. So if I just undo that one, turn it clockwise, and then just undo that one, now I can put the part fully in. So if I tighten that one up, and now tighten that one up, we should be somewhere close here. Nope, nowhere near. Why is that? There's the high. So we'll say that's a high, and that's a high. So this is a low. We're down to about 10. That's a high, that's a low. Well, not to about 10. Should be somewhere close. Okay, that's pretty good there. That's good. And that's only gone out this far, but it's already 3/1000ths out. That's bad. That is bad. Now, the longer the part gets, the further that whips, and that's not acceptable. That is not acceptable. reading should be the same all the way down that shaft. I've shown you it when it's clamped at the end here, very lightly, and I've tapped this side around, and I promise you, I cannot tap this around. This is solid high-speed steel. It will not move, and the jaws won't let it move because it has full contact now. But as you can see here, there's only a couple of tenths, 10,000ths of an inch of run out here. I can get it better, but it's very hard because these jaws aren't ground square, so there's always a bit of movement here. You can never get it perfect when you've got full engagement. The only time you can get it perfect at the front here is when you clamp by only a couple of millimeters at the front here. Anyway, if you clamp it fully here and you've got a perfectly ground shaft like this one is, and it's perfectly straight all the way down like it is, if you clamp it fully, it's whipping out here. Now, if I put a centre in, widen out a bit, if I put a centre into the tailstock, okay, so if I put a centre in, that's still not going to help, because what will happen is the centre will bend the shaft, and when you turn the shaft, it will have a bow in it. It will go wider, and it will go like that. The shaft will get wider and narrower because you're holding it out of position. So even putting a centre in doesn't work, because the chuck is not ground parallel, so it wouldn't matter how good the jaws are. The jaws are cock skewy, they're splayed out. So that's the problem with it. If you look at the shaft, it's not going, it's going, it's not going like that, it's going like that. If it was out of round, it would just be going like this, or like this, but it's not, it's going like this. So if it was out of round, it would be just going like that, but it's not, it's going like that. Look. There's nothing wrong with my setup here. That stayed exactly the same. The only thing I've changed is the chuck. And there must be all manner of things wrong with this chuck, because just changing it round, put the up and down route, oh man, this is bad. This is really bad, this chuck is. 4-jaw test, take 1. Yeah, okay. That's the high, and that's the low. Okay, that's as close as damn it. It's got all these uneven surface, but you know, within 4 thou. And it's going to be perfect in a minute. Absolutely perfect. Right, I have finished the cube. Well, I hope it's going to be a cube. Just needs a bit of deburring on the last side. A big chip hanging off of it. Let's take it out and measure it. Very nice finish. Nearly. I mean, no, it's really nice. There is actually obviously a bit of chatter going on, I think. No, that's really good. Really good. Okie dokie. We're happy with that. That's the hammer falling off. See if we've got a 0 now. Or like 5/10 away from 0, so we'll try the other side on that. That's that one. I want this one round here. And bring it in. Get up to it. And yeah, that's way past 0. Okie dokie. So we're a bit wonky there. So we're going to bring this one in past 0. I'll leave this one here. And just need to tap it in a bit further. There. We'll put the hammer up here, eh? That'll be this one. Anyway, you get the idea, that's what I'm doing, and I'll continue to do that until I get the back face absolutely perfect. Alright, we're money fiddling about. I've got all the faces at the back 0, and also that reasonable. About a thou. So there's a high there. Give that a quick nip there. See what she looks like now. Worse. There's the high there. High there. High. Let's loosen the low this time, because that is just don't seem to be able to do anything with that. And what does that tell you? I know full well that back face is perfect. We are not looking at that yet. So I have two surfaces now which should be parallel to one another. This surface here and this surface here. This outer diameter, which I grabbed onto, has now got chuck jaw marks in it, and obviously to protect the part for the future operations I'm going to have to put jaw protectors in to stop it from being defaced by the steel jaws. Anyway, let's see how parallel I made these two surfaces. They should be pretty good, to be fair. So we've got 35.79, 35.78, oh, 35.72, 35.77, 35.79, 76, 77, 78, 77, 77, 79, 8, 8, 7, 8, 7, 8, 7, 7, 7, 9, 8, 8, 8, 8, 7, 8, 7, 7. So I reckon at the circumference we are within 3/100ths, and in from the circumference there is some different readings, I think. Seven, 6, 7, 5, 7, 6, 7, 6, 7, 5, 7, 5, 7, 4, 7, 6, 7, 7. So yeah, about 3/100ths. Okay, so I've got about 3/100ths parallelism. So I am going to make a square block out of this. Okay, so I'm using the dial test indicator and I'm looking for the low of 0. And the low of 0. So those two faces are central. I don't know about this side and this side, it's about right. Approximately. Good enough, I'd say. Easily good enough. So I'll get the test indicator out of the way. And we're going to surface off this. We've got 35 point... something or other. 35.75 we're going for. And the diameter 50.82. So we're taking 50mm off, so I should say 7.5mm off this side. Ooh. Approximately. Right. Let's set up a 7.5mm removal. So, digital test indicator on there, turn it on, 7.5mm. .48. Seven point 5, 7.46. If I press really hard I can get 7.52, that's close enough. For a start. Alright, let's get rid of the carpet out of the way. Make sure that is clearing. Yes, it is. You get the idea. So I'll just deburr the front of that. I don't know how close to a cube this is going to be, because that isn't what I've been going for. Just been going for parallel faces like that. So I'm going to finish off the rest of the deburr, which will entail a load of 45 being put onto it. This was a lot easier in the chuck. a lot easier. And take the secondary burr off. So we've got a taper. Okay, so that's a bit of a taper. Oh. Let's get us on the surface plate and see if that rocks like that on the surface plate. Right, I got fed up with all that measuring. I just measured it and I didn't go for dimensionally accurate cube. I just quickly measured it and went for quickness. So I took 7.5mm off of each curved face, basically. And it ended up that I've got it 35.7 to 35.4. So 0.3 out of cubeness, maximum tolerance. And that's measured at the centre. It does concave by 0.01. So not a lot of concave, but it does concave a little bit. And the outer tolerance is 0.003 of an inch or 0.09 of a millimetre. So I'll give that a final figure so both imperial and metric people will know. 0.09 of a millimetre, 0.003 out of coplanarness to one another, which isn't bad. So squaring up stuff, yes, this chuck can do it. So that's promising for it. So as a four-jaw goes, so long as you don't want it for shafting, it can do shafts. Let me just do a quick demonstration. So for instance, if I wanted to tidy up this collet, let's bring this collet into view. Okay, come on, into view. So for instance, if I wanted to tidy up this collet and I wanted to chuck it like that, all the way in, basically up to the flange, and then address this internal bore, I can't do that. That is impossible to do in this four-jaw. So changing a part like this from end to end, it can't do it. If you can't do an operation on a part, so if you can't do all operations on a part in one op, then you've had it. So even just putting these threads on, if I want to do all those operations and put those threads on, I can do that, not a problem. But then I want to put a Morse taper in the end of that. Look, yeah, there hasn't got anything in there at the moment, and I want to put a Morse taper in there. So I've got to flip that around in the four-jaw, put it in, and then I've got to set it so it's concentric. Now I can set it here so it's concentric, but the face will have a little bit of run out in it. But I'll never be able to set the face concentric. It won't. It will not happen because these jaws are out of spec. So doing simple parts like this and getting that Morse taper concentric is impossible. That would definitely have to go into the spindle and be done, which is the way this would be done anyway. But you get what I'm saying. You cannot fully chuck apart like that. The only way I could possibly do that is by putting a couple of soft bits of copper in there which are annealed and clamping on it gently and then beating 7 bales of crap out of it. which is going to knacker your spindle bearings and everything. So although we can do a square piece, and I think mainly because I was using the chuck face, so I was beating the cube against the chuck face is how I got the accuracy. Although I can do that, it certainly can't do shafting work and internal bores where you have to swap from end to end. It will not do it. Maybe I should do one of those to prove it. So hopefully I'm going to have some kind of conclusion here. The 4-jaw chuck can be used for certain jobs, but can't be used for other jobs. For instance, this is the puck that you saw me making earlier on, and I've sawn it in half. Not bad, eh? Did that on the little bandsaw. Now I need to set that up in the jaw, and you saw me do it already once. Just set it up so the back face is absolutely parallel, and then face the front end off and cut a bore in it. Not a problem. Should be able to do that dead easy. Mainly because I've only got a small clamping area and I can tap it around and I can get the orientation exactly right. However, this is a shaft and this may be harder. So when I was using this slitting saw arbor, it slipped in the collet and it damaged the shaft. So I want to re-engineer that shaft down to the next collet size, and I will have to hold it in there like that. Now luckily I have got a centre in this and I can just grip it on the end. Just a little bit on the end there and put a centre in and it should be okay. But if that shaft was too long to fit in between the centres, and I had to put the shaft through the spindle and clamp on it at some other point, there would be full engagement on these jaws, and at that point it would be all over the shop. There'd be nothing you could do apart from shimming the jaws, which, who wants to shim the jaws? Nobody wants to shim the jaws. You want to rely on the jaws. The jaw is your reference area. So like I was saying with me 4 out of 10, literally if you haven't got a trustworthy source where you can get a warranty on these things, it's not worth wasting your money on them. It really isn't. And that's my conclusion. Yes, you can use it, but not for all things which 4 jaws can do. So really it's a one-legged 4 jaw. Or a person with one hand missing kind of thing, like, you know what I mean? It's got a thing missing that it could do but it can't because it isn't built properly.